Seismic zone requirements for the installation of light fixtures, specifically 2-foot by 4-foot fixtures, are outlined in the National Electrical Code to ensure safety during seismic events. The United States is divided into seismic zones based on the likelihood of earthquake activity. These zones are Zone 0, which indicates low seismic activity, Zone 1, which indicates moderate seismic activity, Zone 2, which indicates high seismic activity, and Zone 2, which indicates very high seismic activity. In Zone 1, fixtures must be securely attached to a box, outlet, or another approved support. Fixtures weighing more than 6 pounds, or 2.7 kilograms, must be supported independently by an approved seismic support. In Zones 2 and Tube, fixtures must be securely attached to a box, outlet, or an approved support. Fixtures weighing more than 20 pounds, or 9.1 kilograms, must be supported independently by an approved seismic support. Fixtures must be listed for use in seismic zones with a corresponding seismic rating, for example, seismic rating 2 or Tube. Fixtures should be mounted on a rigid surface, such as a concrete ceiling or a seismic-rated suspension system. Electrical wiring should be secured to prevent damage during an earthquake. For fixtures weighing more than the specified limits, the seismic support system should be independent of the fixture suspension system. It is important to regularly inspect fixture installations for damage or loose connections, especially after an earthquake. The specific requirements may vary based on local building codes and regulations, so it is recommended to consult with a qualified electrician and refer to the specific building code requirements for the location of the installation. When installing light fixtures in seismic zones, especially 2-foot by 4-foot fixtures, adhering to the National Electrical Code and local building codes is crucial. The NEC provides guidelines to minimize the risk of damage and ensure safety during earthquakes. Firstly, it is essential to identify the seismic zone of the installation location, as requirements differ based on the level of seismic activity. Secondly, in Zone 1, where seismic activity is moderate, light fixtures must be securely attached to a junction box, outlet, or other approved support. For fixtures exceeding 6 pounds, independent seismic support is mandatory. Thirdly, in Zones 2 and 2, which experience high to very high seismic activity, all fixtures must be securely attached, and those weighing over 20 pounds require independent seismic support. Additionally, fixtures used in these zones must be specifically listed for seismic applications with the appropriate rating. Fourthly, proper fixture mounting is critical. Fixtures should be installed on rigid surfaces like concrete ceilings or seismic-rated suspension systems to enhance stability. Fifthly, electrical wiring must be securely fastened to prevent damage during seismic events. Slack in wiring can help accommodate movement without stressing connections. Sixthly, independent seismic support systems should be separate from the fixture's primary suspension system. This ensures that the support can withstand seismic forces without compromising the fixture's normal operation. Seventhly, regular inspections are essential, particularly after an earthquake. Check for loose connections, damaged components, or any signs of stress on the fixture and its supports. Eighthly, local building codes may impose additional or more stringent requirements, so it is important to consult with a qualified electrician and refer to the specific regulations for the installation location. By understanding and implementing these requirements, you can significantly enhance the safety and reliability of lighting installations in seismic zones. Remember to always prioritize safety and compliance with applicable codes and standards to protect people and property. When selecting a light fixture, especially a 2-foot by 4-foot fixture for seismic zones, several factors need consideration to ensure compliance and safety. Firstly, the weight of the fixture is a critical factor. As the NEC specifies different weight thresholds for independent seismic support in different zones, it is essential to know the exact weight of the fixture. Secondly, the seismic rating of the fixture is vital for Zones 2 and Tube. Ensure the fixture is listed and labeled with the appropriate seismic rating that corresponds to the zone where it will be installed. Thirdly, the mounting options available for the fixture should be evaluated. Look for fixtures that can be securely mounted to rigid surfaces or are compatible with seismic-rated suspension systems. Fourthly, The construction and materials used in the fixture should be durable and able to withstand seismic forces. Consider fixtures with robust frames and secure component attachments. Fifthly, the wiring connections and access points should be designed for secure and easy wiring installation, minimizing the risk of damage during an earthquake. Sixthly, consider energy efficiency and lighting performance. While seismic compliance is paramount, ensure the fixture meets lighting requirements and energy-saving goals. Seventhly, check for compliance with local building codes and regulations, as they may have specific requirements beyond the NEC. Eighthly, review the manufacturer's specifications and installation instructions to ensure the fixture is installed correctly and safely. By considering these factors, you can select a 2-foot by 4-foot light fixture that meets both seismic requirements and lighting needs, ensuring a safe and reliable installation. Independent seismic support systems are critical components for light fixtures in seismic zones. These systems are designed to provide additional support and prevent fixtures from falling during an earthquake. Firstly, the design should ensure the support system is independent of the fixture's primary suspension system. This separation prevents the transmission of seismic forces to the fixture during an earthquake. Secondly, the materials used should be strong and durable. Steel cables, chains, or rods are commonly used due to their high tensile strength. Thirdly, the connection points to the building structure should be properly engineered and installed. Use approved anchors or fasteners that can withstand the expected seismic forces. Fourthly, the load capacity should be adequate to support the weight of the fixture and any additional loads it may experience during an earthquake. Fifthly, the installation should follow the manufacturer's instructions and relevant building codes. Ensure that the support system is correctly positioned and securely attached. Sixthly, the system should allow for some flexibility to accommodate movement during an earthquake without causing damage to the fixture or the support system. Seventhly, regular inspections are crucial to ensure the integrity of the support system. Check for signs of corrosion, wear, or loose connections. Eighthly, consider using pre-engineered seismic support kits that are designed and tested for specific fixtures and seismic zones. These kits simplify the installation process and provide added assurance of compliance. By properly designing and installing independent seismic support systems, you can significantly reduce the risk of light fixture failure during an earthquake, ensuring the safety of occupants and the integrity of the building. When mounting light fixtures in seismic zones, it is essential to use appropriate techniques and hardware to ensure stability and prevent dislodgement during an earthquake. Firstly, surface preparation is crucial. Ensure the mounting surface is clean, dry, and free of debris. Secondly, use appropriate anchors or fasteners that are specifically designed for the mounting surface. Concrete anchors, toggle bolts, or expansion bolts may be used depending on the type of surface. Thirdly, follow the manufacturer's instructions for installing the anchors or fasteners. Ensure they are properly tightened and can support the weight of the fixture. Fourthly, use vibration-resistant hardware such as lock washers or self-locking nuts to prevent loosening over time. Fifthly, when mounting fixtures to suspended ceilings, use seismic-rated suspension systems that are designed to withstand earthquake forces. Sixthly, ensure that the fixture is securely attached to the mounting surface. Check for any wobble or movement and tighten the connections as needed. Seventhly, use safety cables or chains to provide additional support and prevent the fixture from falling in case of failure of the primary mounting hardware. Eighthly, consider using flexible conduit or wiring to allow for some movement without stressing the electrical connections. By using proper mounting techniques and hardware, you can enhance the stability and safety of light fixtures in seismic zones, reducing the risk of damage and injury during an earthquake. Wiring and electrical connections in light fixtures within seismic zones require special attention to ensure they remain secure and functional during an earthquake. Firstly, use flexible conduit or wiring to connect the fixture to the electrical supply. This allows for some movement without stressing the connections. Secondly, secure the wiring to the fixture and the building structure using appropriate fasteners and supports. This prevents the wiring from becoming loose or damaged during an earthquake. Thirdly, use vibration-resistant connectors and terminals to ensure reliable electrical connections. Fourthly, provide adequate slack in the wiring to allow for movement without pulling or straining the connections. Fifthly, protect the wiring from abrasion or damage by using grommets or bushings at entry points. Sixthly, inspect the wiring and connections regularly, especially after an earthquake, to check for damage or loose connections. Seventhly, consider using pre-wired fixtures with seismic rated wiring and connections to simplify the installation process. Eighthly, follow all applicable electrical codes and standards when installing wiring and making connections in seismic zones. By paying close attention to wiring and electrical connections, you can minimize the risk of electrical hazards and ensure the continued operation of light fixtures during and after an earthquake. Regular inspection and maintenance are essential for light fixtures in seismic zones to ensure they remain safe and functional. Firstly, conduct visual inspections of the fixtures and their supports regularly, looking for signs of damage, corrosion, or loose connections. Secondly, check the mounting hardware to ensure it is securely fastened and shows no signs of wear or fatigue. Thirdly, inspect the wiring and electrical connections for damage, loose connections, or frayed wires. Fourthly, test the operation of the fixtures to ensure they are functioning properly. Fifthly, after an earthquake, conduct a thorough inspection of all fixtures and their supports to identify any damage that may have occurred. Sixthly, repair or replace any damaged components promptly to prevent further deterioration. Seventhly, tighten any loose connections or fasteners to ensure the fixtures remain secure. Eighthly, keep records of all inspections and maintenance activities to track the condition of the fixtures over time. By implementing a regular inspection and maintenance program, you can identify and address potential problems before they become serious, ensuring the safety and reliability of light fixtures in seismic zones. Local building codes and regulations play a significant role in determining the specific requirements for light fixture installations in seismic zones. Firstly, these codes may adopt or modify the provisions of the National Electrical Code to suit local conditions and priorities. Secondly, they may specify additional requirements for seismic design and construction, such as stricter bracing or anchoring requirements. Thirdly, they may require special inspections or certifications to ensure compliance with seismic standards. Fourthly, they may establish different seismic zones or classifications based on local geological data. Fifthly, they may provide guidance on the selection of appropriate fixtures and materials for seismic applications. Sixthly, they may require permits or approvals for light fixture installations in seismic zones. Seventhly, they may enforce penalties for non-compliance with seismic requirements. Eighthly, it is essential to consult with local building officials and qualified professionals to understand and comply with the applicable building codes and regulations in your area. By following local building codes and regulations, you can ensure that light fixture installations in seismic zones meet the required safety standards and minimize the risk of damage or injury during an earthquake. When selecting an electrician for light fixture installation in seismic zones, it is crucial to choose a qualified professional who has experience and expertise in this specialized area. Firstly, verify that the electrician is licensed and insured to perform electrical work in your jurisdiction. Secondly, inquire about their experience with seismic installations and ask for references from previous clients. Thirdly, check the knowledge of the National Electrical Code and local building codes related to seismic requirements. Fourthly, ask about their familiarity with seismic-rated fixtures, mounting hardware, and support systems. Fifthly, ensure they have the necessary tools and equipment to perform the installation safely and effectively. Sixthly, request a detailed estimate of the project costs, including labor and materials. Seventhly, discuss the scope of work and ensure they understand your specific requirements and expectations. Eighthly, choose an electrician who is reliable, professional, and committed to providing high-quality workmanship. By selecting a qualified electrician, you can ensure that your light fixture installation in a seismic zone is performed correctly and safely, minimizing the risk of damage or injury during an earthquake. When retrofitting existing light fixtures in seismic zones to meet current standards, several steps need to be taken to ensure compliance and safety. Firstly, assess the existing fixtures and their supports to determine their suitability for seismic upgrades. Secondly, identify any deficiencies in the existing installation, such as inadequate mounting hardware or missing seismic supports. Thirdly, develop a plan to address these deficiencies, including the selection of appropriate seismic-rated fixtures, mounting hardware, and support systems. Fourthly, disconnect the power to the existing fixtures before beginning any work. Fifthly, remove the existing fixtures and their supports, taking care to avoid damage to the building structure. Sixthly, install new seismic-rated fixtures, mounting hardware, and support systems according to the manufacturer's instructions and applicable codes. Seventhly, reconnect the power to the fixtures and test their operation to ensure they are functioning properly. Eighthly, document the retrofit work, including the materials used and the installation procedures followed. By following these steps, you can effectively retrofit existing light fixtures in seismic zones to meet current standards, improving their safety and reliability during an earthquake. Ensuring that light fixtures in educational facilities within seismic zones adhere to stringent safety standards is of paramount importance. Firstly, these installations must comply with all local and national electrical codes, particularly those pertaining to seismic activity. Secondly, all fixtures should be securely mounted to prevent dislodgement during seismic events, utilizing appropriate anchoring systems and supports. Thirdly, independent seismic support should be implemented for fixtures exceeding specific weight limits, as outlined in the NEC. Fourthly, electrical wiring should be securely fastened and protected to prevent damage during earthquakes. Fifthly, regular inspections should be conducted to identify and address any potential issues such as loose connections or damaged components. Sixthly, emergency lighting systems should be equipped with backup power sources to ensure continued illumination during and after seismic events. Seventhly, educational programs should be implemented to educate staff and students about earthquake preparedness and safety procedures. Eighthly, collaboration with qualified electrical contractors and engineers is essential to ensure that all installations meet the required safety standards. By implementing these measures, educational facilities can create a safer environment for students and staff in seismic zones. Implementing seismic safety measures for light fixtures in healthcare facilities is critical to ensuring the safety and well-being of patients and staff. Firstly, all light fixtures must be securely mounted and supported to prevent dislodgement during seismic events, complying with the NEC and local building codes. Secondly, independent seismic support should be utilized for fixtures exceeding specified weight limits, ensuring they remain in place during earthquakes. Thirdly, electrical wiring should be securely fastened and protected to prevent damage and potential electrical hazards. Fourthly, emergency lighting systems must have backup power sources to maintain illumination during and after seismic events, crucial for patient care. Fifthly, regular inspections and maintenance should be conducted to identify and address any potential issues such as loose connections or damaged components. Sixthly, healthcare facilities should develop and implement comprehensive emergency response plans that include procedures for addressing lighting failures during seismic events. Seventhly, healthcare staff should receive training on earthquake preparedness and safety procedures, enabling them to respond effectively in emergencies. Eighthly, collaboration with qualified electrical contractors and engineers is essential to ensure that all installations meet the highest safety standards. By implementing these measures, healthcare facilities can create a safer environment for patients and staff during seismic events, minimizing the risk of injury and disruption to critical services. In commercial buildings located in seismic zones, the installation and maintenance of light fixtures require careful consideration to ensure safety and compliance with built-in codes. Firstly, all light fixtures should be securely mounted and supported to prevent dislodgement during seismic events, adhering to the requirements of the NEC and local building codes. Secondly, independent seismic support should be used for fixtures exceeding specified weight limits, providing additional stability during earthquakes. Thirdly, electrical wiring should be properly secured and protected to prevent damage and potential electrical hazards. Fourthly, emergency lighting systems must have backup power sources to ensure continued illumination during and after seismic events, facilitating safe evacuation. Fifthly, regular inspections and maintenance should be conducted to identify and address any potential issues, such as loose connections or damaged components. Sixthly, commercial building owners and managers should develop and implement emergency response plans that include procedures for addressing lighting failures during seismic events. Seventhly, building occupants should be educated about earthquake preparedness and safety procedures, enabling them to respond effectively in emergencies. Eighthly, collaboration with qualified electrical contractors and engineers is essential to ensure that all installations meet the required safety standards. By implementing these measures, commercial buildings can create a safer environment for occupants and minimize the risk of damage and disruption during seismic events.